So this video is to walk you through how to find the notes for our upcoming unit and a little mini lesson on our notes. So I'm going to get it started. I am on my home page for math. Your home page should look pretty much the exact same without all like the teacher junk on the side. I'm scrolling down. Our units this year, we just finished up ratios, rates, and percents, along with measurements. So I'm going to click on the integers button. That's our next unit. And this pops up. This is our learning target homepage. So if you want to know the specific learning targets that you're going to be tested on and you're going to be practicing, they are on each of the buttons. It's just breaking it up into different sections, basically. So I'm going to click on my first button here. It's integers. And as soon as I do, the learning target shows up, correct? This is our continuum. So what does it look like in a getting started versus in progress versus mastery when you're talking about integers? Okay. And for each of these buttons, you're going to find a link to the YouTube channel. I always want to make that easy. Your may do button is if you have excelled and you have permission, you can click on that. And there's a whole bunch of online games that I found for you guys just as an added perk. And the notes button is what I want to show you. So as soon as you click on the notes, this is what pops up. And instead of going through it like this, because all my teacher junk is still on the side, I've opened up a separate window just so we can kind of go through it together. So if you look, starting off on your notes, just like always, these are in your folder as well, right? So in your folder, the first page is your learning targets, right? And it's all of them. So we start off with integers, which is just positive and negative whole numbers. Okay, of course, we have to give fancy names for stuff. And then absolute value. Okay, and then we move on to geometry. So lines, angles, and graphing is the technical section in like your Empower and in your learning targets. But basically what you're trying to do is find the distance between points. You're also trying to reflect an ordered pair over the X and Y axis, and you want to be able to plot in all four quadrants this year. So I'm going to explain what that means too. Okay. So that's page one. Moving on to like the actual lesson part of this video, what are integers? These are your notes. So whenever I say refer to your notes, it's going to make it a lot easier. If you look, you guys, integers are positive and negative whole numbers, right? So any positive number, any negative whole number. 0 is not considered positive or negative, so it's not really in the category of being an integer. Okay. So I'm just kind of giving you an example. If you have 0 on a number line, right, everything to the right is a positive, everything to the left is negative. Some kids have known that for a long time. Other kids still struggle with that a little bit. So if you notice, it's a mirror image, right? +1, -1, +2, -2. So they mirror out from one another. Okay. Numbers get greater, right? They're more when you move to the right. And numbers are getting smaller when you move to the left. Well, this is weird because if I look at -1, -2, -3, the actual digits themselves are getting bigger, right? 8, we've learned, is bigger than 1. But because it's negative, right, you're actually getting less. You're having fewer as you go left. It's almost like the opposite world. Okay. I always refer to money when I'm talking to kids. Do you want to be in debt $1 or do you want to be in debt $8? Clearly, you don't want to be in debt $8 because that means you have even less money, right? So as you go further down, even though the number itself is bigger, the value is less. Okay. You're in debt even more. So I almost think of it as like you're digging a hole, right? You go down 1 feet, 2 feet, 3 feet. So the further down you're getting. Okay. So that's just an intro. Remember, integers have to be positive numbers or have to be whole numbers. I'm sorry. They can be positive or negative, but they have to be whole numbers. So we're not going to be talking about decimals. We're not going to be talking about fractions when we're talking about integers. Okay. So the next part is like, can you compare them and figure out which one is greater than and less than? Can you put a couple of integers in order? That's the next skill set. So again, left is less. The further left you go on a number line, the less you have. Okay, so 5, right? If I go left, 3 is going to be less than that. 1 is less than that. -2 is less than that the further left you go. Okay, so an example of a problem you might get for -5, 0, and 2, can you put them in order from least to greatest? Okay, so you're just telling me which one has the least amount of value. Okay. When comparing negative numbers, the greater the digit, the less the number's worth. And I already said that, right? Think of it like debt, right? -5 is worth less than -2, right? Which one would you rather be in debt for? A debt of $500 or a debt of 6, right? So think of it as having less money than that. All right. So the next part is opposites. Okay. So our opposites is actually, I'm going to go through and make sure I'm not forgetting anything. It is not. Okay, cool. Our opposites are literally what we talked about, our mirror image on a number line. Cool. So pretend you take a number line and you fold it in half with your 0. These are going to touch, right? They're exact opposites of one another. That's literally what the word opposite number means. Okay. They're pairs with the same absolute value but different signs. So what that means is this is a 1, this is a 1, but they have different signs. This is a positive, this is a negative. Okay. So the opposite of +5 would be -5. The opposite of +2, -2. Okay, so your opposites just have different signs. That's literally it. Okay, not hard. The reason why we need to know that is because the next stage we're going into is absolute value. Okay, absolute value is asked or represented by these, I call them goalposts, right? It's kind of like the little football goalposts, right? So when you see these lines wrapped around a number, they're asking you for the absolute value of that number. Okay, what is absolute value? How do you find absolute value? Count the units between the number and 0 on a number line. An absolute value is literally how far away is that number from 0 on a number line, right? So if I say, what's the absolute value of -5, right? I've got the goalposts. I'm asking for the absolute value of -5. I'm saying how far away is -5 from 0 on a number line. You wouldn't say it's -5 away, right? You would just say it's 5 hops away. It's 5 spaces away, right? 5 units away. I tell kids the way that you can think of absolute value is let's say I'm running, okay? Ha ha ha. Good joke. Okay, so let's say I'm running and I decide I want to run 5 miles, correct? If this is my house, if I'm at 0, right? I could run 5 miles this direction. I could run 5 miles this direction, right? I would never say I ran -5 miles today, correct? Like that's not even a real thing, okay? Even if I run backwards, it is still running 5 miles, right? So when you start to think of it like that, absolute value is always a positive amount, right? Because it doesn't matter which direction you run in, it's still going to be a positive value when you share it with someone. I ran a mile, I ran 10 miles, I ran 14 miles, right? It doesn't matter if you're in the positive direction or the negative direction on a number line, okay? So these are your examples over here, okay? The absolute value of -72, I'm literally just asking you, how many hops away from 0 is -72? It's 72 hops. So that's the whole reason why it's a positive amount, right? What's the absolute value of 13? I'm just asking you, how many hops is 13 from 0 on a number line? It's 13 hops, right? What's the absolute value of -8 and 4/10? All I'm asking is how many hops is -8 and 4/10 from 0 on a number line? I would hop 8 and 4/10 of a hop. Okay, so notice they're all positive. Okay, and I want to point this out because remember, all I've been stressing about what's an integer. Integers are positive and negative whole numbers, right? Well, you're seeing a decimal right here. So your brain may be saying, whoa, 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 we're not supposed to be dealing with decimals. This section of our unit is an absolute value. Absolute value can be with fractions, it can be with decimals, it can be with whole numbers, okay? Because if I'm trying to run, right? If I legitimately tried to run a mile right now, I would not get the whole thing ran. So I would end up with a fraction of the mile, okay? With absolute value, it's the same concept. I could have negative 1.5 hops, right? Would be right here on my number line, right? Going in the negative direction, 1 hop, but I don't make it to 2. I'm only halfway to the next one. So I'd be right here, correct? So if I asked you right now, how many hops am I from 0? Well, I'm 1.5 hops from 0. So that's the whole reason why you can have halvesies, you can have any kind of fraction, any kind of decimal with absolute value. Okay, because it's just how many hops you are from 0. Cool. All righties. Let's see here. Our next section is okay. So there's actually 4 sections to this unit, and the last part of it has to do with your coordinate planes, okay? Which is just a fancy way of saying, like, you've been graphing stuff for quite a few years, right? But you have basically been focusing on what they call quadrant 1. Quad is just kind of a fancy way of saying 4, okay? So there are actually 4 quadrants when you're graphing, and that's because you end up having a y-axis that goes vertically and an x-axis that goes horizontally, okay? That's because when you're trying to travel, right, or plot anything, you can go up or down. You can go right or left. So instead of just always being in this quadrant, like as a little kid, you've always been given numbers where you walk forward and then you climb up, right? Well, now we're moving on beyond that. Now we're saying you could start off and instead of going forward, you go backwards, okay? And instead of going up, you may go down. Okay. So that's the only reason why you end up with 4 quadrants is because you're going in different directions than what you're used to. Okay. It's not scary. You just have to get used to it, really. Okay. Um, so the way that I remember it, it makes a C for coordinate plane when you're trying to remember which one's which, because you'll be given plots and you're going to have to tell me which quadrant you're landing in. Are you landing in this one, this one, this one, or this one? So quadrant 1, I always tell kids that one's easy to remember because it's the first one you learned, right? The first one gets a number 1 in it, right? You learned all positives as a little kid. And then you just go counterclockwise, which just means the opposite direction of a clock. Or you can say you draw a C for a coordinate grid, right? So then you have quadrant 1, quadrant 2, quadrant 3, and quadrant 4. These are Roman numerals and they freak people out, but that's all that means. 1, 2, 3, 4. Okay? We'll get more into that in just a second. So again, you're always starting at the origin. An origin, I mean, people even ask you, what's your origin, right? People do those ancestry.com places or whatever. That's to find your origin, where you came from, where you started. Okay. So the origin where you start when you're trying to plot is always 0, 0. It means you haven't gone left or right and you haven't gone up or down. You are at 0, 0. Okay. I love this guy right here. This may look a little weird and overwhelming, but I like this part here. Okay. Because you always start at 0, 0. That's literally what origin means. Start there, right? And you're always going to move sideways and then you can go up or down. Okay. So the way I try to explain it, let me move on. Here we go. Perfect. Okay. So I try to say you're starting at your origin, right? And your first number that you're given in an ordered pair tells you how you're going to walk. The second number in your ordered pair is going to be how you climb or go down. Okay, so I'm just going to give you some random examples here. Okay, da-da-da. Let's do pink. Okay, so let's say I give you the ordered pair for -2. Okay. Ordered pairs are always written in parentheses. Okay. It's just to kind of cluster them. And they're called an ordered pair because there's a pair of them and they're in a particular order. Okay. So the first number is always left or right. Okay. I'm going to put LR. Okay. The first number tells you if you're going to go left or right. The second number tells you if you're going to go up or down. Okay. So some kids catch on super quick. Okay. If you're going to go forward, that's a positive. If you go backwards, it's a negative. Some kids kind of get confused with that. If you're climbing up, that's a positive. If you're going down, that's a negative. Okay. So starting at my origin, I'm right here. Okay. And this is all one big travel. Okay. And what I mean by that is you are not plotting two different places. It's actually one dot. You're going to end up with one dot when you're done. Okay. I'm going to show you the movement before and then I'll erase it. So this is telling me I need to go +4. So forward is my positive amount. So I'm going to go 1, 2, 3, 4 hops forward. Okay. Then my second number from here says I need to go -2. Negative means down. So I'm going to go down 2. 1, 2. And I would end up right here. Okay. So what that means is that is what I would plot. You don't actually have to keep any of this. You're not supposed to. I mean, if you need to write it in order to get it correct, awesome, go for it. But then erase it because this is your true answer. Okay. The ordered pair of this dot is 4, -2. Okay. The way that I try to remember it or teach it to kids is just the real world. Okay. So think about it. If you are trying to get on an elevator, right? When you enter a building, right, you have to walk. You have to figure out where you're going, right? You can go right, you can go left. Okay. Then when you find the elevator, then you can choose to go up or down in your elevator. Okie dokie. You don't like climb into your elevator and then go sideways in your elevator. I don't know. It makes sense in my brain. So that's what I always say. So you're walking and then you're climbing or digging. Okay. So let's try a different one now. Okay, here's your next example. Okay, so I also want to bring this into play, the X and the Y. This is your ordered pair. This is the order that you always have to go in. It's the whole reason for the name, right? So the order is you always go along the X and then along the Y. So for the most part, when you get started, if you notice, your axis is labeled. So this is my X axis and this is my Y axis. So this kind of tells you visually, hey, if I have to do X first, it means I have to go along here first. Then I get to do Y, and Y means up and down. Okay, so that's another good reminder. Okay, I always try to remember another thing. You know how my brain is. I have so many of these, right? Okay, so if it's not labeled, okay, here's some other helpful hints. Okay, I always remember that if I'm trying to figure out which order, correct? This is alphabetical order, right? X, Y, Z. That's our end of our alphabet, right? So put them in alphabetical order. So it'll tell you which one you do first. And then if you're looking at these and you're like, what the heck? They're not even labeled. I remember that I can take this line and actually make a big fat Y out of it. Okay. Okay. Can I make an X out of the other one? No, but I can't make a Y out of the other one either. So this, I don't know. This always helps me. Okay. I can make a Y out of this. So I know this guy's the X one. Okay. So helpful hints, alphabetical order and the Y axis, you can actually draw on it. Cool. Okay. So here we go. We are going to start with -6. Okay, so I'm always at the origin, right? 0, 0. I haven't moved left or right, and I haven't gone up or down. Okay, my first number is -6. I automatically read this as backwards 6. Okay, or you can say left 6. Okay, start getting in that habit when you read it. So I know I need to go in the negative direction 6 hops. Some kids get in the habit early on where they're starting to count. So they go 1, 2, 3. You're not counting spots, okay? If you're here, you can't say you walked a mile. You haven't done the squat, right? So you can't count it until you've moved. All right. So that's why I very dramatically make these hops in front of you because I want you to count with me. 1 hop, 2 hops, 3 hops, 4 hops, 5 hops, 6 hops. Okay, so I went -6. Okay, I didn't start where I was at and say 1, 2, 3, because when you're just standing there, you can't say you've already gone 1 mile. Okay, you have to actually go there first. Okay, so now I'm at -6. My second number is 5, +5. Okay, positive means I'm going up. I am not digging down into a hole. Okay, so positive means up. So I'm going to go up 5. 1, 2, 3, 4, 5. Ta-da. Okay, cool. So now again, like I said, you want to go through and none of this matters. Okay, this is just kind of like your work to get there. It's awesome. It helps you, but at the same time, this is your only answer right here. This dot represents -6, +5. Okay. The other little oopsie weird mistake that kids kind of make is they actually count boxes. And then that really like messes you up. So I don't know how they would start here, but I do know kids tend to do that. Like they want to say like this is 1, this is 2, this is 3. Oh, I think that's how they would do that. So like they would say this is 1 box, 2 box, 3 boxes, 4 boxes, 5 boxes, 6 boxes, and for some reason they end up putting their dot there, like in no man's land. Okay. And then they count 5 boxes by saying 1, 2, 3, 4, 5, and you're just counting the boxes. You're not counting the boxes, you are counting the distance from one spot to another. Okay, so that's all you care about is getting to the other edge of the box. You're not actually counting the space itself. Cool? Okay, here's a new one. You try this. Okay, so just kind of pause the video and try it out on your own. Okay. Remember, your first letter is always what you do on your x-axis, and then your second is what you do along the y-axis. It's not a letter, it's a number, sorry. The first number is what you do on the x-axis. The second number is what you do on the y-axis, okay? So it's a left to right option, and then it's an up or down option. And it all just depends on if the number is positive or negative, okay? Pause the video, try it out. Okay, so if I'm at -7, I know I'm starting at my origin and I'm going to count 7 spaces. 1, 2, 3, 4, 5, 6, 7 hops to get over to that space, right? And now it's -2. So I know my second number is what I do along the y-axis, right? It's up or down. And since it's a negative, I know that means down. So I'm going to go down 2, and this is where I end up. Cool. So that is my final answer. Not the whole thing, just that dot, right? Cool. And then just to point out, which quadrant am I in? Okay, this is your first one where everything's nice and positive, right? And then you're going to draw a C, for coordinate grids, right? Or you can just say counterclockwise. So this is 1, this is 2, this is 3, and this is 4. Those are your quadrants, right? So if I'm landing here, I know it is quadrant 3, okay? The last part of this page of notes is not just this part, what I've been showing you, but over here as well. So I like this. This is kind of showing you again the X and the Y. X means your left or right choices. Your Y is your up or down choices, right? So I give you some ordered pair examples, and I'm telling you what you would do, right? So if it's a -5, you're going to go left, right? If it's a positive, you're going to go right. And then if it's your second number, if it's positive, you go up. If it's your second number and it's negative, you're going down, right? Okay. So anywho, that's the next part. Now, I do give you another page. So when you come to me in small group, I have a blank grid and then I have practice problems as well. So we'll do that whenever we all get together. I'm not going to do it right now. And then this part here, the last 2 pages are a little bit more complicated. So don't jump right into it unless you feel very comfortable plotting your 4 quadrants. Okay. So here we go. Here's the next part. This part is reflections. So I don't know if you realize this, but when you look at your reflection in the mirror, you're actually seeing the opposite of what everyone else in the world sees. It's crazy. So if you ever look into like a double mirror, you're starting to see what everyone else sees, and it freaks me out because it's not how I think I look. So anyway, reflections are the opposites, just so you know. So just to kind of solidify that concept, if I was going to reflect a smiley face over this line, right? It means I'm flipping it like a pancake, is what I say. Pretend I'm taking that spatula, I'm shoving it underneath the smiley face, and I'm flipping it over here, right? It would not just look like this. Okay, that's not flipping a pancake, right? That's just like sliding a pancake over, correct? So if I'm actually flipping it with a spatula, and I remember the fact that reflection means opposite, it's going to look like this. Ta-da! Yeah? See how it would be like a flip of a pancake? Cool. Same thing over here. So if I have a smiley face here, but I have, this is what I used to do all the time as a kid. Bleh. Little tongue. Okay. So if I'm flipping it over a line, a vertical line, right? And I want to flip it like a pancake over, right? Pretend my spatula is sliding underneath that smiley face. The tongue's no longer going to be on the right side. Pretend, like, take your hand up to the screen and pretend like you're flipping it over. That pancake is now going to have the tongue on the other side. All right. Okay. So that's what I mean by when I say reflections or opposites. So if you have your notes out right now, I would write the word opposite right next to this. I'll spell it for you very slowly. Sorry. I really wish that I could get a writing pad. Okay. Okay, so moving along, a reflection, we're actually taking our coordinates and we're going to reflect it. We're going to flip it like a pancake, okay? And then we have to tell what quadrant it is landing in. Okay, so the first thing I need to do is actually plot, okay? So 4, -2. I'm going to look up here. Here's my origin, right? And I'm going to go +4, -2. +4, -2. Down 2. So I'm right here, correct? Okay. I am kind of baby stepping you into this because the numbers are on here. I really do prefer eventually, especially with our dry erase boards. You'll notice I bought boards that don't have numbers on them. Cool. And I do that on purpose because I don't want it told to you directly that this side's positive, this side's negative. That's something you just have to kind of start remembering. So this will baby you into it. But then once you actually get like a test or when you're practicing with me in small group, I don't give you these labels. Okay. That way we can kind of start trying to remember it. So anywho, +4, -2. Now what I want to do is reflect over the y-axis. So the first thing is, what the heck's the y-axis? Is that this guy or this guy? I don't have it labeled. Do you remember what the wonderful way to remember which is which? If you have my brain, then you're already thinking, this is my y-axis because I can make a long y out of it, right? Okay. So that means this line right here is what I'm flipping my pancake over. So I'm not sure where it's going to land, but I know for sure if I flip this pancake, this itty bitty pancake over the line, it's going to go whack somewhere over here, right? So I can already tell what quadrant I'm going to land in, right? What quadrant is this? Thinking back, this is obviously my first quadrant. Everything's positive. Then I'm going to go counterclockwise, right? So first quadrant, second quadrant, third quadrant, right? So before I even plot it, I know I'm going to flip that pancake into the third quadrant. Cool. Ta-da. All right. Now let me magically show you this. What were my numbers? 4 and -2. Before I even work, I'm going to say 4 and 2 stay, no matter what. The only thing that changes when you reflect, when you go from quadrant to quadrant, or if it's positive or negative. That's the only thing that changes. So without even like thinking about anything else down here, I can look at this problem. This is -3, -6. Well, when I reflect it, no matter what I'm reflecting over, my numbers are still going to stay 3 and 6. Cool. When I have 2 and 6, no matter what I'm reflecting over, they're going to stay 2 and 6. I just don't know if they're going to be positive or negative yet. Okay. Same thing here. Look at this fancy little guy. It says -1, -5. Reflect it over the X and then over the Y. So I'm flipping it twice. I'm going crazy with this pancake. Okay. So it doesn't even matter. I just know for sure I'm going to end up with a 1 and a 5 in my quadrant, like in my ordered pair. I just don't know if it's positive or negative yet. Okay. So I hope doing this early is kind of reinforcing. Your numbers stay the same. Okay. They're just moving around with positive and negatives. Okay. So again, we're flipping over here, right? So I know I need to have a 4 and a 2, and they have to be in this quadrant. Well, think about this. Any number in this quadrant, no matter what it is, any number in this quadrant, to get here, you have to walk first, right? So that means I have to have my first number be negative, because when I'm walking, I have to go negative direction, right? So in order to get over here, it has to be a negative, right? And then to get down here, I have to go down. So no matter what, I have to have a second number that's negative, because that's what makes me go down into this quadrant. Cool. So now if I want, I can kind of go off of this. I turned it into -4, -2 just by using quadrant logic. Okay. So now I can go 1, 2, 3, 4, and then -2. 1, 2, and I can plot it right here. Okay. Another way of doing that, but honestly, it doesn't give you quite as much number sense. I love it if you can just look at the quadrant and know if it's going to be positive or negative. That's when you truly understand like what's going on with these quadrants, okay? But you could also say, when you're trying to reflect, find that y-axis that you're reflecting over, right? This guy right here. Yeah. And check your original. How far away are you from that line? I'm 1, 2, 3, 4 hops to the right. So I need to go 1, 2, 3, 4 hops to the left. And just by doing that, I know I have a mirror image. Okay. But I don't want you to just do that and not have an idea of if you have positive or negatives. Okay. So let's try the next one. Okay, so I erased everything because I want you to try to remember this. Okay, so we have -3, -6. I want you to come up here and plot that. -3, -6. Where would that be? Okay, go ahead and try to do that. Take your finger and plot it. So if I'm starting at the origin, -3, the first number always tells me left or right. So if it's negative, I'm going this direction, right? So I'm going to go 1, 2, 3. -3, -6. So my second number is a negative. And that means if my options are up or down, that I have to go down. 1, 2, 3, 4, 5, 6. Okay, so I'm right here. Cool. So now the next thing I want to be able to do from here is look down. It says reflect over the X axis. Okay, so if I'm here, which one's my X axis? Well, again, our handy dandy way of remembering things, this guy can turn into a Y, right? So that means this guy's the X. I have to flip my pancake, right? Shove the spatula underneath there and flip it over the X axis. So that means if I'm flipping it over this line, you can think of it too as just the word jump. When you see reflect, just think of the word jump. So when it says reflect over the X axis, jump over the X axis. So if I jump over the X axis, I have to end up over here somewhere, right? Okay. So again, using like quadrant logic, okay, I know my numbers have to stay the same. 3 and 6 will stay no matter what. I know by flipping, I'm going to end up here. So if this is quadrant 1 and I make my C, then I know that this quadrant is quadrant 2. Okay, so I'm going to make this a quadrant 2. So if I'm going to end up somewhere up here in this quadrant, right, and I know it's 3, 6, those have to be my numbers. Let's look and see. If I am starting in my origin and I need to get over here, right, it means I have to walk backwards and then up to get there, correct? So backwards is a negative direction, up is a positive direction, right? So that means I know for sure I'm going to have a negative 3. I got to go backwards, and a positive 6 because I have to go up in order to get up here. So I'm going to show you 1, 2, 3, negative 3, and then positive 6 is up here. Okay. The other way of looking at it is if it asks you to jump over the x-axis, just know you have to do a mirror image over the x-axis. So ask yourself, how far are you? 1, 2, 3, 4, 5, 6 down. So the image, the opposite image, the mirror image would be 6 up instead. Okay. Either way, but I really want you to get the concept of the positive and negatives in different quadrants. I'm going to have you go through and try the next 2. Pause the video, and then I'll give you the answers right away. So that way I can move on to the last lesson. Pause the video and I will show you your answers. Okay, very quickly, if you have positive 2, positive 6, it means you're right here, correct? And it's asking you to reflect over the y, jump over your y-axis, which is right here. So that means you're going to end up over here. Okay, so you're going to end up with a negative positive number. So that's where I get a negative positive number, and that's quadrant 2. The next one and the last one, I am going to kind of walk you through a little bit more. So you start out at -1, -5. So that means it's a -1, -5. You're right here, okay? And it's asking you to jump twice, reflect twice. So that's why I'm going to work it out. So when you reflect over the x-axis, you're flipping or jumping over this is the first thing you're going to do is the x-axis, right? So this is your x-axis. Yes, yes. So I'm going to take this guy and go whoosh, over here somewhere, right? Then it asks you to flip over the y-axis, which I'm going to whoosh, end up over here somewhere, right? So I know I'm going to end up somewhere in this quadrant, correct? So that's why I need to know, is my positive 1 and my positive 5 correct? If I'm here, everything has to be positive, right? Positive, positive. Okay. And this is my first quadrant. Cool. All righty. All right, this is your very last page of notes and the very last lesson. Okay, so you're still using your coordinate plane and you're trying to find the distance between points. Okay, the main thing you're going to do is without graphs. So kids try to kind of cheat and use their graph. And what I do is I end up just taking the graph away from you and I make the numbers so big that you can't even create your own graph on your paper. So keep in mind when I say no graphs, eventually you will literally have to do it without any kind of grid in front of you. Okay, so I'm going to go through and just kind of show you how I do this, and then you can figure out if you would like more support or not. Okay, so we're trying to find the length of the line. Okay, so to start off with, you're not using a grid, but you can kind of use a little fake helper. Okay, so I make my X and Y axis just so I can remember. If I start here, I know to get anywhere over here, I have to go positive, positive. If I went over here, I know I have to go negative, positive. If I went anywhere over here, I know it has to be a negative, negative number. And if I'm going to end up over here, I know it has to be a positive, negative. Okay. So I just use this as like a way to help my brain. So I'm saying, I'm just going to roughly guess, where would 4, -2 be? So I know I have to go forward 4 and down 2. I'm just guessing. Okay. Where would 4, -6 be? Well, it would be the same movement over, right? Because they're both 4. But I'm going to go -6. So I'm going to go even farther down. Okay. It doesn't matter. It's just giving me a visual. I'm trying to figure out how long this line is. Yeah. So if you notice this pattern here, one, they both ended up in the same quadrant, correct? Two, I'm going to show you this. Okay. When you're looking at your ordered pairs, notice that the fours match, right? That's the whole reason why it's a straight line, because we went over 4 for both of them. Okay. So when they match, you don't care. You're just ignoring those. Okay. What I do care about are these two. The way to figure out the distance between -2 and -6 is just a subtraction problem, right? Or you can just count forward: -2, -3, -4, -5, -6, right? So if I just take 6 and I'm subtracting 2 from it, I know that the length of this line is 4 hops long, 4 units long. Cool. The second one, I have -3, -5, -4, -5. Okay. So what I've noticed right off the bat is they're going to end up in the same quadrant because they're all negatives, right? So -3, -5, just guessing. Okay. -4. So I'm going to go a little bit farther over, but I'm still going to go -5. Okay. So see how they're both in the same quadrant? I'm just trying to figure out how long this is. Okay, so again, I'm kind of stacking my numbers, stacking my ordered pairs, and I'm going to see, after I get a visual of this, what do I need to be doing? Okay, what numbers match? My -5 matches, right? So I can just ignore these. That was just to tell me that they're a straight line, right? So what's the difference between -3 and -4? 1 hop. So that's how I know the length of the line. All right, last example. Again, here is my little fake grid to help my brain, right? So I have I have a 4, 2 and a -6, 2. So I'm going to kind of act that out. So I'm going to go +4, +2, just guessing. And then I'm going to go -6, +2. Okay. I do know that these numbers both match. They're making me go up 2 on both of them, right? So when I go to stack these, okay, that's what's going to match. That's what I get to ignore, right? Cool. So I'm going to erase the 2s. That's what helps me know that I'm coming up with a line. This one's different though, guys, because notice they're in different quadrants. Dun, da, da, da. So this is different. Okay. I'm trying to figure out the distance between 4 and -6. Well, this is the whole reason why absolute value even falls into this section with the quadrants. Like, how the heck does that all go together? Okay. So I'm going to ask you this. When you start out at the y-axis, right, and I'm trying to get over to this -6, how many hops is that from the y-axis? I went 6 hops, right? That's 6 hops, right? Even though I went in the negative direction, it's still 6 hops. So technically, I just found the absolute value of -6, right? And then if I take that y-axis again and I say, how far over did I hop to get to 4? 1, 2, 3, 4 hops. Okay. Technically, what I just did was find the absolute value of 4, right? Ta-da. So the absolute value of 4 is 4. The absolute value of -6 is 6. So your rule is you want to be able to combine the absolute values, right? Because if I went 6 hops here and I went 4 hops here all together, it's 10 hops long. So it's 10 is your total, right? So that's why I love to do this little fake X and Y axis, because it lets me know if they're going to be in the same quadrant or different quadrants. If they're in different quadrants, that's when you have to just start adding how far each of them is from your axis. Okay?